lastly, an important term before we finish this video, proposition, is that if a series is convergent, okay, so if this is a sequence that whose sum converges to a finite value, then the limit of the general term of the sequence that's inside the sum, it's going to be 0. Okay, this is kind of a mouthful, but it's important because this is an important point that many students have trouble distinguishing. Okay, so I want to be make a lot of emphasis on this. Okay, so you have the sequence a sub n from n equals 1 to infinity, and then you have s sub 1 is a sub 1, s sub 2 is a sub 1 plus a sub 2, s sub 3 is a sub 1 plus a sub 2 plus a sub 3, blah blah blah, s sub n. Okay, a sub 1 plus a sub 2 plus a sub 3 plus blah 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 plus a sub n. Well, if the limit of this, okay, the limit of s sub n is some value, let's call it a, okay, then this implies that the limit of a sub n, okay, this term, only this term is 0. Okay, so what does it mean in terms of, kind of intuitive terms? It means that when you're summing things, okay, and you have a sum that has an infinite number of terms, this means that in order for the sum to get to a value that's not infinity, okay, the large, the final terms of the sequence have to be very, very, very small, okay, very close to 0. Okay, so how do we prove this? Okay, the proof for this is very easy, actually. So suppose that this is actually convergent. So this sum a sub n, this from a sub n from n equals 1 to infinity exists and is some value a that's smaller than infinity. Okay, so it's a finite value. Then again, so this means that this limit exists, right? Now, if we compute s sub n minus s sub n minus 1, as we have done in many of the exercises in the last unit, when we did Stoll's theorem and stuff, this sum has all terms up to a sub n, and this sum has all these terms up to a sub n minus 1. So if you subtract this sum from this sum, what you're left with is a sub n, right? Now we take limits in both sides. We have the limit when n goes to infinity of s sub n minus the limit when n goes to infinity of s sub n minus 1 is the limit when n goes to infinity of a sub n. But this limit is this limit, okay, a. And this limit also is a. Okay. Both limits are the same. So you have a minus a, which is 0. Okay. Okay. So remember the difference between this term inside the sum and the whole sum, please. It's very important. Okay. So this result you can express in different way by saying that if the limit when n goes to infinity of a sub n is not 0, then this sum is not convergent. Okay? It is not going to be convergent. So for instance, if you have this sequence a sub n is minus 1 to the n, okay, so this is the sequence minus 1, 1, minus 1, 1, minus 1, 1, and so on. So then you have the sum from n equals 1 to infinity of a sub n is just minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, minus 1 plus, and so on. Okay, so if you take the value, so if you have the sum s1 is minus 1, right, s2 is minus 1 plus 1, which is 0, then s3 is minus 1 plus 1 minus 1, which is minus 1, s4 is minus 1 plus 1 minus 1 plus 1, which is 0, and so on and so forth. So the values of these sequences, minus 1, 0, minus 1, so on and so forth. So the odd terms are -1, the even terms are 0. So as you can see, this sequence, the sequence of the sums is alternating between two values as well, 0 and -1. Okay. So yes, remember again the difference between the sequence of the sum and the sequence that's the original with which we built the sum. Okay. Or for another example, you can use the sum from n equals 1 to infinity of 1 over the nth root of n. Well, we know that this is going to be plus infinity. Well, it's not we can say that this is first, it's not convergent. Okay, we know using this result. Why? Because the limit when n goes to infinity of the general term here, 1 over the nth root of n, this is going to be 1. Okay, so imagine as n is very large, you're summing 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 infinite times. So actually, yes, this is going to be plus infinity. Okay, you're going to sum many times the number 1, or something that's very close to 1. Okay, so please remember to distinguish between the behavior of the sum of the terms of the sequence and the behavior of this original sequence. Okay, now if the limit of this sequence is not 0, then the sum of its terms is not convergent. But if the limit when n goes to infinity of a sub n equals 0, then we can't say anything about the series. Okay, but you can say, well, but we have this proposition: if the series is convergent, then the limit of a sub n is 0. Yes, but this is the converse statement. If the limit of a sub n is 0, then this series doesn't have to be convergent. And for example, we have proven this before: 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus blah 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 plus 1 over n plus blah blah blah, which is the limit when n goes to 1 to infinity of 1 over n. Okay, this is called the harmonic series. Okay, now we saw it last unit, last video. This is plus infinity. Okay, because this is asymptotically equivalent to the logarithm of n, right? And the logarithm of n is its limit when n goes to infinity is plus infinity. Okay, but the limit when n goes to infinity of 1 over n is 0, right? So this, you could say, well, this has to be convergent. No. Okay, so let me try to explain it. In order for a series to be convergent, you need the terms of the sum, okay, the terms of the sum, the terms when you go for larger n to be smaller and smaller and smaller and very close to 0, right? But you need them to get smaller very quick, right? And if they get to 0 not quick enough, then this sum keeps increasing and increasing and increasing up until you get to infinity. And I know it's crazy, but that's what happens when you deal with infinities, right? It's something that's out of your mind. You can't really imagine what it means to sum an infinite number of things, okay? And in this case, it's, you know, it's kind of the best example of that. Yeah, it's how you sum 1 plus 1 half plus 1/3 plus 1/4. I'm summing something that's smaller and smaller and smaller and smaller all the time, so it should get to something that's finite. But that's actually not the case. Okay, so remember that, you know, you have to be very careful when computing the convergence of series, because you don't have really rules that apply always. Okay, so remember this: if a series is convergent, then the limit of its this term in the series, it has to be 0. But if the limit of this sequence is 0, then the sum of all its values can be any value. Okay, it could be infinity, it could be something smaller than infinity. Okay, so that's it for now.